Yann LeCun says JEPA is the future of AI, but a Reddit researcher asked the real question: what if there are red flags nobody is talking about? A researcher posted on the machine learning subreddit asking for devil advocates for JEPA. They are doing world model research for robot learning, and JEPA keeps coming up. They have read LeCun's papers and other research group work and personally think the approach is promising. But after listening to Yann LeCun at recent conferences, his pitch of JEPA feels almost too good compared to everything else. He is dissing LLMs, RL, and other approaches while saying his ideas are the only next big things. The question is simple: are there red flags about JEPA that the researcher does not see yet? Where are the biggest downsides compared to other world model approaches? One commenter named SlayAEUW raised what they called their pet peeve with JEPA. There's an emphasis on abstraction at the same time as wanting to compete with general models. Predicting abstract representations is more efficient, but the abstraction necessary is completely dependent on your target task. You might predict a car driving path great, but when you try to predict detailed information, you fail. LLMs are kind of able to smear out everything into something that makes sense regardless of the task. The commenter pointed out that hierarchical abstractions might be the solution, but that is not something JEPA-specific, and it is really unclear how to train such networks. Another commenter, Madramax, pointed out that JEPA does nothing to address fat-tailed distributions. The model uses an isotropic Gaussian to estimate a distribution, while information theory is pointing to the fact that interesting information lies in the ends of heavy-tailed or fat-tailed distributions. On the other hand, the JEPA model cares about a Gaussian latent structure, while thinkers like Taleb focus on fat-tailed physical variables like economic outcomes. Various neural whitening transformations, including diffusion modeling, flow modeling, normalizing flows, and even VAEs, can map between Gaussian latents and non-Gaussian inputs and outputs. Successfully training such a model depends on reasonably robust data sets. The primary pitfall of interesting heavy-tailed distributions is that it takes an impractically large sample. A commenter named Rogue Stargun pushed back, clarifying the isotropic Gaussian is not used to estimate a distribution in JEPA. The regularizer forces the embedding representation to have an isotropic Gaussian distribution to prevent model collapse. If the number of latent variables is lower than the embedding dimension, the true latent gets smeared over the embedding dimensions. SlayAEUW acknowledged this, noting their real concern was that the end-to-end training recipe, including data normalization, Atom W, batch norm, and L2 weight decay, all assume Gaussian input by default. This is not JEPA-specific, though, and was more of a general rant about deep learning infrastructure. Two commenters raised the same point about LeCun's attitude toward LLMs. Namer Not Literal argued that dissing LLMs and RL is more political than anything for Yann. His dislike for LLMs is less about technical capabilities and more about how they have overtaken a massive swath of research and funding, collapsing most of the field into one paradigm. Resident Positive 4122 pushed back, pointing to LeCun's very public criticisms of LLMs around planning, math, and error compounding, and noting that 2 years later, LeCun was wrong on all three fronts since modern models can now do all of those things. A commenter named Smallpaul, who is not a researcher, asked a practical question. Investment in AI in total has exploded since it became so commercially relevant. Are we sure that the absolute dollars dedicated to non-LLM work has gone down? One would think that with billions flowing into research, some fraction must be going into non-LLM models, and that even that fraction must be fairly large in absolute numbers. Yann's own company being funded is a great example, along with Fei Lies, Collitz, and Sutton's. But Ricky, also a practitioner, responded with a different concern. Since there is suddenly big money in LLMs, it drains the best minds from the ML field. So even if other subfields have more financing in absolute terms than before, there is a lack of available brain power. Cosmolithe raised a fundamental objection. JEPA is less principled than generative models because it produces a representation where the information contained is basically up to chance. There is no mechanism that forces the representation to keep useful information beyond inductive biases and data augmentation transforms. Generative models form representations useful to predict raw data. So everything deducible from predicted raw data is necessarily contained. They gave the example of car dashcam predictions. If the model consistently predicts a frame showing a car turning right, the representation must contain information about both the car and its direction. Blahrig offered a summarizing perspective. JEPA is doing mostly self-supervised prediction of missing spatial and temporal information. If it is not using useful representations, then the predictions will be bad. The argument is that latent space is better to predict in because it factors away useless noise, since most of the raw signal is noise. There is probably useful research in using generative approaches in the latent space and/or in further tuning the latent representations via generating pixel-level data. And Project Treadstone noted a practical concern. In JEPA, they perform poorly on a two-room dataset that is the simplest task for other models. So learning what to drop is going to be a bigger task than forcing everything into an isotropic distribution. The devil advocate case against JEPA is not that it is wrong, but that its assumptions about abstraction, Gaussian structure, and information preservation need serious scrutiny. The full breakdown is on the channel. Thanks for watching.